Good evening, and thank you very much, DG sir, for giving me the opportunity to host the session. So, ladies and gentlemen, it is my privilege to welcome you to this thematic session on harmonization of quality assurance provisions for solar energy technologies, held as a part of 8th Assembly of the International Solar Alliance. As we accelerate towards a global clean energy future, solar technologies, both photovoltaics and thermal, are playing a transformative role. From megawatts to gigawatts, from rooftop to solar park, the development is rapid and expensive, but with this growth comes a critical need, quality assurance. Solar energy, by its very nature, it's intermittent in the nature and variable, changing with the location, day and time and season. To ensure safety, reliability and performance, we must embed quality at early stage, from design, manufacturing and deployment and operation as well. This is not just a technical necessity, it is a strategic enabler to bankability. In this session, we will explore how test standards, codes and institutional mechanisms can be harmonized across ISA member countries. We will be hearing from the leading experts and institutions like IEC, NICE and SECI, who are shaping the future of solar quality assurance through rigorous testing, certification, and regulatory interventions. ISA is committed to supporting its member countries through initiatives like the Global Quality Assurance Manual and the STAR-C program under Global Capability Center. These efforts aim to build institutional frameworks, foster regional collaboration, and strengthen capacity for testing and certification. So with this, I kindly invite the guest for our keynote speech, His Excellency Mr. Peter Neema, Minister Energy from Papua New Guinea. I request him please take a seat on the dais. I request Dr. M. Rihan, Director General of NICE, please come on the dais and take a seat. I'm looking for Honorable Minister from PNG. Okay, so I know the schedule is a bit tight today. Please come. So directly jumping on my initial presentation, short presentation to setting up the context, may I request to open the first presentation, please. So the harmonization of quality assurance and provisions. I am categorically not mentioning a term standard here because we need to be on a common platform. I know that journey of solar is really encouraging, but not uniform across the globe. Several markets, several countries it is commercialized, and several countries are just initiating. So the way I'm, trying to structure this is, please, first of all, whenever you are thinking or talking about solar, it should not like that solar PV modules are coming in your mind. It's just a technology, but the market and the globe is flooded with n number of technologies and solutions. So there is solar PV, there is solar thermal, and now there are parallel technologies, especially battery energy storage system, and lot of now, as Mr. Sharma has mentioned, that the way SECI has developed the hybrid and FDRE type of projects. So it's not solar only, but quality control is essential for all segments. Next slide, please. Yeah, so If we see solar energy technologies, I'm sorry, I'm not going to go into deep dive on and just elaborating what solar energy is, but just in order to set the context, among all energy sources, whether it is conventional, whether it is nuclear, whether it is non-conventional, the uniqueness of solar energy is its variability. It can give you the solution from milliwatt, autonomous powering of a watch or a calculator screen up to gigawatt. And we can consider both as a project. None other technology gives you this flexibility. And same thing with the solar thermal, it can give you a temperature of up to temperature of sun. It means up to 5 to 6,000 degrees centigrade we are talking about. Already, around 3,200 degrees centigrade through solar concentrator has been achieved. But if you see our applications, maximum it is up to power generation, it is around maximum 700, and some industrial processes might be up to 1,200 degrees centigrade. So you know that we have lot of flexibility, and lot of applications could be developed around it. And then we are talking about energy storage clubbed with solar. So it is also following same type of trend. It can give you milliwatt hour to megawatt hour, even gigawatt hour. So one side it is very good that we are having this much of range or this much of bandwidth of application, but other side we need a proper quality control mechanism for it. Next one please. So why quality control is important for solar? And as we are having the delegates from multiple countries, 10-15 years back when solar journey was started in India, this was the big question. If we are having a solar PV module, how it will be surviving for climatic condition like in India? Because if you see, India is ideal example for worldwide whatever climatic conditions are existing, all India is experiencing. Our bandwidth of ambient temperature is from -60 to +50. So we are having 6 climatic zones and we are having a typical test standard, and that is working. So there is a difference in solar and basically the thermal. Thermal is I will say very simple to predict in terms of its firm and dispatchable things. We know that there is some specific calorific value associated with coal. We are burning in a closed chamber, closed physical conditions. But solar is not like that. Some module manufacturer can give you guarantee of efficiency, guarantee of its surface area, but nobody can guarantee the sun. And that's why this is very, very critical. So the quality assurance is not only in terms of setting up and testing and standards, but how you are going to implement those standards through which specific institutional mechanism, that is very important. And this is the uniqueness of India. And this is the story which could be replicated in other part of the world. Next slide, please. So on this slide, I'm just trying to establish that how this implementation mechanism in India is working and how this could be leveraged. So there are academic institutions like IITs, our universities, they are working on research and developments. There are test standard developing institutions like IEC, Bureau of Indian Standards, ISO. So the studies are being converted in form of test standards, and then these are implemented by government. So there is a separate department called Bureau of Indian Standards, which actually make all standards mandatory. They do basically all sort of research, whether adopting international standard and do them Indianize, or whether developing separate standard, as in solar thermal, lot of Indian standards are existing which are different than others, global standards. Then it comes to NABL, who actually accredit the laboratories who do these type of testing and do the certification for manufacturers or the developer. And there are test centers like National Institute of Solar Energy and some private institutions who do the testing and standardization within the country. And if you see the way it is structured, guidance is given by, just putting one step back. So when we are talking about the product, testing and standardization is being done by institution, but when we are developing a project and implementing on a grid, then Central Electricity Authority comes with a guidance. And as per their guidance, the compliances of grid code and other safety measures, one need to follow the guidance. CEA usually, give those guidances. Then Ministry of New and Renewable Energy is there, which is having their under their portfolio as NICE, I have just mentioned. Solar Energy Corporation of India, who does auction and introduce new type of products, and institutes and financial institutions like IREDA, who is basically dedicatedly, financing renewable energy projects, and today they are having a portfolio of around 27 gigawatt capacity. So next one. So what exactly we are proposing? So ISA member countries, we are having Star C. They are working with the Star C, and Star C will be linked with the GCC, which ISA is structuring, Global Capability Center. And Global Capability Center will be having interaction with and participation with the NICE or TUV and these type of testing entities. So this is the holistic structure we are proposing. This is two dimension. What is? First one is we are willing to develop a global capability, quality assurance manual, and then how to implement that implementation mechanism. So this is on nutshell what on testing and standardization we are proposing. With this, I will kindly request Mr. Peter Naima for keynote speech on this. Thank you.
Good afternoon. Esteemed colleagues and friends, distinguished delegates, ladies and gentlemen. On thematic session, Harmonization of Quality Assurance Provisions for Solar Energy Technologies. It is a great honor to join you today at this pivotal thematic session hosted by the International Solar Alliance. We gather here not only as energy ministers, policymakers, and stakeholders in the solar energy sector, but as architects of a sustainable future, one that is powered by clean energy, guided by innovation, and anchored in trust. Solar energy technologies are at the heart of the global energy transition, with projections estimating over 4.6 terawatts of solar PV capacity by 2030 and 560 gigawatts thermal already deployed through solar thermal collectors. The scale of transformation is unprecedented. But with this scale comes a responsibility to ensure that every solar installation, every component, and every system meets the highest standards of quality and reliability. Quality assurance is not a technical formality. It is a strategic imperative. It is the foundation of investor confidence, the guarantee of safety, and the assurance of long-term performance. When we speak of quality, we speak of fitness for intended use, a commitment that solar technologies will deliver expected outcomes in a safe, sustainable, and bankable manner. Across the world, countries have made commendable progress in establishing codes, standards, and certification frameworks. International standards such as IEC 6125 for modules, IEC 62109 for inverters, and IEC 61427 for batteries have become benchmarks. In the solar thermal domain, standards from BIS, ICO, and ASHRAE are being adapted to suit local conditions. These efforts are vital, but they must now evolve into a harmonized global framework, one that enables interoperability, scalability, and mutual recognition. India's leadership in this space is exemplary. Institutions like the National Institute of Solar Energy, NISE, TUV Raynal, and UL India are conducting rigorous testing aligned with both national and international standards. The Solar Energy Corporation of India, SECI, and the Central Electricity Authority, CEA, have embedded quality assurance into procurement and grid compliance frameworks. These are models worth emulating. The International Solar Alliance, through its STAR-C initiative under the Global Capability Center, is uniquely positioned to facilitate this harmonization by leveraging best practices and supporting member countries in contextualizing international standards. ISA can help build solar ecosystems that are resilient, investor-friendly, and globally competitive. Today's session is not just a technical dialogue. It is a strategic conversation we must deliberate on. How international standards can be adapted to local contexts, how STAR-C can institutionalize quality control across ISA member countries, how tenders can embed enforceable quality clauses, and how stakeholders can manage and mitigate risks during implementation. Let us commit to a future where solar energy is not only abundant and affordable, but also trusted and transformative. Together, let us build a global solar community that thrives on excellence, collaboration, and shared purpose. Thank you.
Thank you very much. With this, I kindly invite the esteemed speakers of the session, Mr. Vimal Mahendru from International Electrotechnical Commission, IEC, Dr. Biranji Bora, Deputy Director Technical from National Institute of Solar Energy, Mr. Sridhar Singh, General Manager Solar Park from Solar Energy Corporation of India. Please come on the dais and take a seat. I request Honorable Director General ISA for his opening remarks. Thank you, sir.
Ladies and gentlemen, thank you. There's a lot of information flow, but our job is to be the knowledge repository. So apologies if it at 4:30 sounds like a heavy discussion. Testing and standardization are essential for solar energy technologies to ensure safety, reliability, and performance, which in turn fosters market confidence and drives industry growth. Testing evaluates the durability and efficiency of solar panels under a range of conditions, while standardization creates a uniform baseline for quality that benefits manufacturers, investors, and consumers alike. The appropriate quality assurance measures enhance the performance and reliability, safety, market growth, and consumer trust, supports grid integration, enable international trade and collaboration, and encourage innovation and continuous improvement and promote sustainability and environmental impact. Support for testing and quality control of solar technologies has been a continuous key ask from every minister that I have met, whether at the RCM or my visits. It's a key ask, and today we are taking initiatives in the direction of three parts. First, development of a quality assurance manual for solar energy technologies and systems, be it for modules, inverters, batteries, collectors, water pumping systems. Support the member countries to establishment of an institutional framework, as Dr. Purohit mentioned, to enable quality assurance practices and certification effectively. And for that, we are very pleased that we are exploring collaboration with National Institute of Solar Energy, NICE, MNRE Government of India, of testing and capacity building through the Global Capability Center, under which Star Seas will serve as regional test centers. ISA and NICE are strengthening this partnership and working on this implementation plan, which we hope to come back to you by end of this calendar year. NICE, as you all know, is a pioneering institution in India, which conducts the testing and certifications of solar energy technologies and systems as per globally accepted test standards. To support ISA member countries on mapping of solar resources through high resolution and accuracy and developing the standard tools for decision making. This is the third part I want to say, because there are a lot of solar atlases that are available, but there is a need for having a very customized solar atlas available to our member countries. Harmonization of the codes, test standards, and technical specifications of solar energy technologies could address the quality control risk, enhance bankability, and ensure the long-term reliable performance of solar energy projects. The speakers of this specific thematic sessions are therefore an ideal mix of proprietor of test standards, as IEC person is there, testing and certification institutions by having NICE, and solar project auction and execution entity by having SECI. I'm sure all the countries would be benefited through familiarization with the testing and quality control practices and processes of solar energy technology and systems. This is just the start of the journey, but a very important program that ISA is committed to. Thank you very much.
Thank you, sir. With this, I invite the first speaker of the session, Mr. Vimal Mahendru from IEC for the presentation. Please. IT, please flex second presentation.
Thank you very much, Mr. Ishan. First of all, namaste and thanks for the opportunity to be here amongst you today. I want to especially thank the Honorable Minister, Director General Khanna, the Excellencies and the delegates for this opportunity to actually talk about something I'm personally very passionate about. That is standards, sustainability, and our shared future. For this, I have a short presentation in which I will be talking about some of the key aspects. But I'm delighted that IEC already has been mentioned several times, so I don't need to talk about the 100 years or more that IEC has been around for standards and standardization work. I'm also delighted that there was mention of direct current technologies by Mr. Mendonca from Siemens. Director General Khanna mentioned AI engineers not knowing electricity and electrical engineers not knowing AI. Hopefully I will try and address that, as well as Ms. Gurleen in the earlier presentation on Sunrise technology. Sunrise, she was talking about battery circularity and the circularity standards for that. Hopefully I'll address all of this in the next 12 minutes. IEC, I'm sure you are fairly familiar with. It's one of the oldest standardization bodies in the world. Let me go on to the next one. Why do we do what we do? In reality, the world around us is totally evolving. There is a convergence of technologies. Electricity is no longer just electricity in the conventional sense where there were power plants, transmission lines, substations, and then distribution and consumption. It's all becoming a mishmash because each one of us can personally also generate electricity on the rooftop. So it's becoming an all-electric and connected society. This is requiring a new way of looking at standards and standardization so that every consumer becomes a producer of electricity and every producer is also a consumer. This is a paradigm shift that we see. The second thing that we are seeing is end of the day, even standards, conformity assessment, whatever we are saying, all this is not helpful if we are not able to address sustainability. That is at the heart of all that we are doing. So sustainability has to be addressed. If we are not sustainable, then what? That's the question that we need to answer together. And the third, international organizations like the ISA or the IEC, they exist through trust of their members. IEC today has 173 member countries, and we carry with us the trust of 173 countries collaborating on writing meaningful standards for the world. Since we are talking about solar PV, there's a lot of text on this slide, but I just wanted to share, if you want to go through A through Z of solar PV related standardization, not just the silica that goes in or the solar PV panels or how to test them, how to install them, how to manage them, operate them, train the people who are using them, train the people who are going to be maintaining them. Also for end of use life of solar PV panels, all those standards are written in IEC. Of course, there is an extra slide which is hidden right now, which lists all the standards that are part of this compendium that we have. Quality of work is also very critical. That's the reason why IEC has a renewable energy conformity assessment program where we are issuing certificates for projects and products that are complying to IEC standards. This is a very important work that we do. Some of the key components are mentioned here, but this IECRE also looks into complete projects as well. Direct current. There was a time we were only talking about HVDC, which was about taking a lot of electrons from one place and transporting them long distance to another place, many times between countries also. Direct current technologies have evolved. There is now need for medium voltage DC, so that once you have transported, the consumption also has to be addressed. So that's where medium voltage DC, so that from substation downstream, also DC technologies can be implemented. Low voltage DC. In this hall where we are all sitting, my voice that you hear, the lighting, the screens at the back, these are all working in DC natively. It is only some archaic systems which lead us to still have alternating current coming to the walls, and then we use adapters or transformers to convert AC to DC so that we can consume electricity. Why not have solar PV panels on the rooftop and consume directly as in DC itself? That is where real energy efficiency kicks in. And IEC is doing standards for HVDC, MVDC, and LVDC. Interestingly, in September, that is this year, last month, the IEC had its annual general meeting in India in this very hall, and India secured the Global Secretariat for Direct Current Technology Standardization. So this standardization work is being led by BIS in India now. When we talk about solar PV in rural electrification, there are multiple use cases and applications. Of course, we've heard about lighting. IEC has standards which comply with the World Bank multi-tier framework for electricity access. We are already writing standards for solar-based PV cooking, solar PV-based cooking solutions, also for refrigeration for clinics and health centers in rural communities. So there is a lot of work which already exists in this. Circularity is important because I heard it in several of the sessions today. Of course, IEC is writing complete set of standards for circularity, or how to even manage circularity. The main idea is to deliver material efficiency, address circularity in the design itself, something which came up in the first session also. And third, which is absolutely critical, is the carbon footprint verification. That is equally important to make sure that the process of creating circularity is not itself becoming a burden on the system. Last but not the least, IEC this year is also once again participating in Brazil in the COP30. If some of you are there, please welcome to the IEC pavilion. I will personally be there to receive you, and if there is anything that we can try and address together, it will be a pleasure. The main purpose of being in Brazil is also to bring our message to the global community, but also to listen to you. And that's why being here in this session has been very helpful, because I'm taking back a lot of inputs which I can go back to the bunch of geekish engineers who will at least know what the world is expecting of us. This is the last slide, and I always try and conclude with this question. What kind of world will our children and grandchildren inherit? I grew up in a small town in India, in Punjab, where clean air, clean water, I could drink from any stream or tap. It was never a concern. Unfortunately, we cannot say that today. Is this real development? To really create meaningful development, we need to do more. Something that our children and grandchildren are proud of. And when I address that, this is really at the heart of what I'm trying to do at the IEC, leading to an all-electric, connected and sustainable world. We are looking for growth through this initiative, and very humbly we would like to support all the initiatives that ISA is taking. Thank you for this opportunity. Thank you.
And thank you so much, sir. IEC is a pioneer institution, and globally standards are being followed by solar industry. With this, I request Dr. Bora from National Institute of Solar Energy for presentation how they are implementing IEC test methodologies in testing and certification.
Honorable dignitaries, I would like to thank ISA for having us here to talk about what we are doing at NICE regarding this testing of solar PV modules and systems. So as we know, India is going for installation of big PV power plants. So in this particular case, NICE is working in the testing and certifications of different components of PV power plants. We have different verticals at NICE. However, in terms of testing, we have facilities like solar radiation calibration facility, module testing facility, then solar thermal system facility, battery testing, water pumping, inverter, as well as solar lighting testing facility. So I will go details about what are the standards we are following in this particular case. So before going to that, I think in India, we are following the quality control order released by Ministry of New and Renewable Energy regarding these solar PV modules and components, where if you want to sell any components in the market, then first you have to qualify as per these standards. There are different standards, IS standards you need to qualify, which is somewhat equivalent to the IEC standards. For crystalline silicon PV modules or thin film modules, you have to qualify this 14286 as well as 6170. Then storage battery here and inverters for power systems as well as utility grid. So there are different standards which is need to be compulsory. You need to first test the system as per this, then only you can enter the market in India. Coming to the test facilities at NICE, we are having facility testing of PV modules as per different IC as well as IS codes for PV modules. These are the tests for type testing, as well as we have testing facility for bifacial panel also. Other than our QCO, we are also having facility for testing of PV modules for an energy rating, as well as salt mist corrosion or potentially induced degradation testing, which is one of the major requirement in Indian climatic conditions, because in some of the climatic conditions we have high humid and high temperature regions, as well as salt content maybe there in the environment. So that's why in some of the tenders, these are the standards people used to make it mandatory. Other than that, we have facility for outdoor testing, as well as we are doing the long-term performance testing of PV modules, and we are checking the reliability of the technology, what are the degradation, what are the reliability issues for different environmental conditions. Also, we are in the business of checking the power plant health, as well as performance guarantee assessment for different power plant for different climatic zones of India. In case of inverter testing facility, we are having facility for testing the efficiency of the system, as well as safety of the inverters, or also regarding this islanding and or battery surge controller testing facility we have. Also, we have facility for doing the testing of IP testing. We are having a big facility for this IP testing. We can do up to 2 meter by 2 meter systems for these particular cases. For solar lighting systems, in India right now, we don't have any standard mandated by quality controller order. So that's why MNRE has specified some technical specifications which is related to the LED-based systems, where you can, the manufacturer need to check their product as per these MNRE specifications, and if they are qualified, then only they can sell in the market. Also, we are having facilities as per LM79 and IS 16106, which is not mandatory yet for these Indian cases. For battery testing facilities, we are having facility for testing of lithium-ion LED as well as nickel-cadmium batteries for different sizes. For solar water pumping systems, also in the same case, in the same way, we don't have any particular standard for these solar water pumping systems, because in India we have 6 climatic zones. Already Dr. Ishan mentioned about that. So for 6 climatic zones, our radiation level and temperature level are different. So based on that, what will be the passing criteria for a particular pump? This need to be decided, and that's why MNRE has specified some technical specifications based on the hot and cold climatic conditions, and based on that, their procedures are developed, which is followed by ministry. So other than that, we are also having facility for this IS 17018 as well as 62253 IEC standards. We can do this test as per these particular cases. We are also offering the calibration services to different stakeholders. One is the calibration services regarding the radiation measurement devices like pyranometer or reference cells, where we are having traceability with respect to WRC, World Radiometric Center. We are offering these services now. For golden module calibration, you can say reference module calibration, we have established this facility, or we are doing the testing as per IC 60904. For this facility, our uncertainty level is less than 1.6%. In terms of PMAX, we can go for 2 meter by 3 meter by 2 meter module, and we can give the golden module to the different customers. Also, we are having facility for solar simulator calibration. This is, I think, if you know about this technology, then we have to check what is the solar simulator people are using to do the testing, and it should be as per, there should be some light stability should be there, non-uniformity should be checked, need to check the spectrum. So we are offering these services also. We are doing the solar simulator calibration on-site for different cases. Also, we are having a facility for electrical and thermal calibrations. For solar cell and material characterization, we are having facility for, we are having classic clean room facility where we are having different equipment to do this characterization of the solar cells before making the solar cells, as well as after making the solar cell and before going to the module itself. We are having facility for, in terms of solar thermal, we are having facility for solar cold storage testing, where we are checking the, as per the, actually there are no particular standard right now available either in the IEC or BIS. So that's why NICE has developed these testing standards and for these particular cases, and we are doing these tests for solar cold storage. NICE is also capable of developing the in-house test procedure where there is no standard available. Like right now, there is no standard available for cleaning devices of PV module in terms of reliability and performance, as well as also there is no standard for nano coating that is applied to be applied over the PV modules. There also NICE has developed in-house test procedure as well as solar AC and solar PV-based induction cookers. There we have already developed some standards. Recent contribution of NICE regarding these drafting standards is the one of the requirement is the we need to develop the guideline for solar water pumping systems where there is no testing procedure available. So NICE has developed that. NICE has also developed the testing procedure for the solar lighting systems for India. Also developed the series guidelines for different PV module with different bill of materials. NICE is also involved in the quality control of PM Surya Ghar Yojana, and NICE has developed the market surveillance of PV modules because at the time of measurement of a PV module in the lab and what is the product is going in the market, that need to be checked. So for that actually NICE has developed a mechanism for these particular cases. NICE was also involved in the development of star rating for the PV module and inverter and quality control order of MNRE, as well as testing the standard development for the solar cold storage. I think this is from my side. Thank you.
Thank you very much, Dr. Bora, for being so crisp and focused. And as you know that NICE has always been doing pioneering work in area of testing and standardization. Recently, NICE has published a solar potential map for India using very high resolution satellite data. With this, I will invite, I'm inviting Mr. Sridhar Singh from Solar Energy Corporation of India to share the perspective how SECI is taking quality control measures in their auctions and projects. Thank you.
Yeah, good evening, Honorable Minister for New and Renewable Energy and distinguished guests. So I will just start regarding the practices to ensure quality and performance standards in solar auctions. The ISTS, it's related to ISTS solar tenders, where connected solar projects enabling pan-India power trading through transparent e-auctions happen. The quality standards we follow, compliance framework ensuring project meet MNRE, CERC, CA guidelines and grid codes. Then the payment security is there, which gives a robust financial mechanism providing security to developers and ensuring project bankability and investor confidence. And finally, the developer benefits with a 25-year PPA, which has got a easy bankability, and the LOA security is there and a long-term revenue certainty for the solar power developer. So the ISTS solar tenders of SECI are located pan-India and are connected to the national transmission grid, enabling efficient power trading across states. The structured tender framework combines transparency, quality assurance and financial security to attract leading solar developers and ensure project success. This is also we are following the rigorous quality framework where all projects have to comply with MNRE, CERC, CEA technical standards, ensuring long-term reliability and performance. The payment security mechanism is there, which ensures that the developer have confidence and the bank and the project is easily financed. The technical standard verification and compliance checklist what we follow is the CEA connectivity certificate confirming grid interconnection approvals. Then we check the lease and land documents with clear title so that the project never lands into future troubles or problems. Regulatory and grid compliance, wherein the state nodal agency approves the renewable project. We have got the long-term access from the central utility and CERC regulation compliance for tariff and scheduling and grid operating parameters. Core technical standards, we follow CEA regulation and compliance framework. All solar projects adhere to CEA technical standards for connectivity to the grid, regulations 2007, amended in 2019 and subsequent updates. All components also conform to relevant IAS IEC standards for quality, safety and 25-year service life. The modules have to qualification standards which are as per the different IC standards for different types of module types. Like crystallines have to be IEC 61215, thin film IEC 61646, concentrator has to be as per IEC 62108, safety testing IEC 61730, and corrosive environments have to comply as per IEC 61701. Performance and warranty standards, strict performance warranties ensure long-term reliability and energy generation. So we have got standard conditions which the developer has to apply for the modules which he is procuring. The PCU and the cables and components, all these have to be as per the IC standards, and they have to be warranted for a minimum 5-year comprehensive coverage. The cables and balance of system also have to follow all the IC standards. Performance monitoring is so performance monitoring also happens where when all the measurements have to be reported to the sites to the central monitoring unit, and the module also has to be, as RFID tag is there, which we can check the manufacturing details and everything of the modules. The modules have to be ALMM compliant and documentation is required. Also, the safe disposal and end of the life management is to be ensured by the developer. Grid compliance, CERC regulation and interconnection, ISTS interconnection, ISTS and intra and interstate interconnections as per CERC and SERC regulations have to be ascertained. There has to be a grid interconnection standard also, all designed compliant with grid code, safety standards and operational procedures for stable, reliable integration. Connectivity requirements and transmission responsibility. The connectivity must comply with the CERC General Network Access detailed procedures. The CTU approval for connectivity configuration specification has to be ascertained, and transmission system responsibility is full responsibility vests with the developer. Construction of transmission lines as per specification and wheeling charges and all other charges have to be borne by the developer. Metering, energy accounting and forecasting also vests with the developer, and he has to bear everything. The pooling substation and multiple project configurations. Individual project energy recording and SPD signature is required. Energy accounting divided and early demarcated per project. Transmission losses between pooling and ISTS substation apportioned. All these are into the scope of the developer, and reactive power and everything has to comply as per the grid requirement, and this is also established by the developer only. This is the general network access which is taken by the DESCOM, the power consumer, and the connectivity and mitigation requirements. Developer has to maintain connectivity and operational compliance throughout the PPA tenure to avoid any default scenarios. The project is commissioned wherein a 60-day notice has to be given to SECI, and based on that, SECI does the inspection and all, and 7-day notice is given to RLDC and buying entities for trial run and repeat trial run commencements. These are the technical documents which are required. It is basically the connectivity application which you make to the CTU, the CEIG approvals which you have to take for all the plant you have established, metering arrangements approval from the CTU grid we have to take, and compliance and approval certificates, all like plant layout and SLDC and all approvals, they have to be taken before this plant gets finally commissioned. So trial run and COD and inform power offtake. The trial run process validates project readiness and establishes commercial operation date. Developer must submit COD certificate confirming installed capacity. So trial run notice, 7-day notices to be given to SECI and RLDC also. And this, after that, the trial run is over, the COD is declared and the power supply starts. The performance bank guarantee encashment happens only when in case of a default. There are certain conditions based on which the default is established. Otherwise, if there is no default or if there is a force majeure, then extension can be given. There is a special payment security mechanism which makes the developer have confidence in SECI, and there is also a tariff protection and a back-to-back PPA structure. It's the same payment security mechanism. So you can see that in the past 5 years, there has been a substantial growth in the tender execution by SECI, and it is really a success which we can see we have achieved. So I on behalf of SECI would like to invite everyone to follow, to give us a chance to work with you. We can have a better interaction and develop your system so that you can also gain success like we have done in the past. Thank you.
Thank you, Mr. Singh. And with this, we came at the end of the session. So I request Dr. Mohammad Rehan, Director General, National Institute of Solar Energy, for a brief way forward and closing remarks.
Honorable President, Assembly, Co-President, all the other dignitaries, all the guests, ladies and gentlemen, a very good evening to all of you. Our colleague from IEC talked about the importance of electricity in the modern world, connected world. So, in electrical engineering, we used to refer to a major power failure as blackout. But in this modern world, keeping lights on is probably the least important thing, because electricity is running our whole world. And that is why it is important from the point of view of ensuring sustainable development. So that guides us, our initiatives, our developments, and I'm sure you have heard about the way we have adopted solar energy from 10 megawatt in 2011 to 130 gigawatt, and then numbers for 2030, 2047 and 2060. And the 3 NDCs and 5 Panchamrit goals are our guiding principles. But when we talk about this transition, it is keeping sustainable development in mind. So the quality assurance is also an integral part of sustainable development, because you want the product to serve you for its complete life. That is where this testing and standardization is an integral part of sustainability issues. And this panel has, this session has very comprehensively covered all the initiatives, all the important parts. I'll try to summarize what has been our experience, what is our, the system which we have developed. So basically it involves, first is the institutional foundation. So we have Bureau of Indian Standards, which follows the IEC and other international standards, and keeping track of that and updating the standards. And they have a dedicated sectional committee to solar PV systems also. Then the institutes like National Institute of Solar Energy. So NISE is not simply a testing lab. Basically, we work with the industry and we ensure, we try to work in the way that the product is tested as well as it is improved also. Then we have institutionalized the policy and incentives which link quality with incentives. For example, our ALMM scheme, which ensures the manufacturing good practices, better quality, as well as our PLI scheme, which incentivize the higher efficiency, production of higher efficiency components. Then we have tried to develop multiple affordable, practical, decentralized testing centers and systems. And very important part is training the workforce also, because you need people who can conduct these tests, who can properly conduct these tests. And one more thing which I would like to highlight is the use of digital tools, data transparency and traceability. So we have, in our institute itself, we have developed a portal through which we are following all the modules in the first stage for those projects which are centrally funded, and it may be extended later to other modules also. This is helping in ensuring quality, as well as a very important issue is how to address the recycling of these panels when they complete their life. So if we have this traceability, this will help us in implementing a system for their recycling also. So this is, in this session, we have broadly talked about the setup, how we work in our country. And we look forward to share our experience with you in detail also, and to learn from you also what is your experience in, and how we can assure the quality in the area of solar energy, extending to all the components involved. So with this, I thank ISA for making us a part of this and arranging such an important discussion. Thank you so much.
So this is the end of the session. May I request for a group photograph of all distinguished guests and panelists? Thank you so much.